Righto, okay, so question 1. 2x equals 5. I'm going to divide both sides by 2. Divide the left by 2, divide the right by 2. Believe it or not, somebody got that wrong. Next one, 2 plus 3x equals 7. Right, now the way I showed you was this construction-destruction method. So if we do it that way, the first thing I do is look at the x, and I say, how can I construct the whole of this thing? Well, I multiply it by 3, and then I add the 2. So I do it in reverse. I subtract 2 from both sides first, and now once I've done that, I now divide both sides by 3. Okay, another point, by the way, going back to question 1, when you divide by 2, just divide by 2, okay? Don't write it as a decimal. Okay, if I want to divide 5 by 2, I just put a line underneath it and put a 2 underneath. I don't even have to think, really. Yes, but why? Why do it? Right? And there's a good reason for that, is that if I had 2x equals 3, let's say 3x equals 2, what would I write then? 2/3, what, 0.6 recurring? Looks nasty. Suddenly we've got these recurring decimals coming along. No, just divide it, okay? Yeah.
We're always taught if you can put it in a decimal, it's a decimal.
Well, it's wrong. Simply wrong. Okay? Next one, 5x minus 1 all over 3 is 1. Again, if you're doing this construction method, look at my x. First thing I do is multiply by 5. Then I subtract 1 to get the numerator. Then I get to the denominator, divide by 3. So we go reverse. First, multiply both sides by 3. Oh, and by the way, guys, listen carefully. So many of you are not doing the same thing to all of both sides. You're doing it to bits of it. So if I'm multiplying by 3, I must multiply the whole of this left-hand side by 3. Not just a little bit of it, but all of this by 3. That gets rid of the 3, and all of this times 3. Now in this case, it's a simple example, but when we get to the more difficult ones, you'll see where you may have gone wrong. Okay, so that's that. Now add 1 to both sides. That's that. And now divide both sides by 5. Again, don't need to think. 4/5. Question 4. 2 brackets x minus 3 equals 7. No, I multiplied by 3, both sides by 3. I multiply this by 3, 3's go. Multiply this by 3, I get 3.
So you do the opposite of both sides.
Yeah, the opposite in each case and go backwards through the list. Okay? So here, 2 things you can do. You could multiply the brackets if you want. Okay, let's do it both ways. Or you could do it the construction method. So if we start with the x, the first thing I do is subtract 3. Then I multiply all of that with 2. So I'm going to do the opposite of that now. So the opposites are backwards and opposite. Divide both sides by 2. And then add 3 to both sides. And then I'm going to just simplify this fraction now. 3 is the same as 6 halves. So I get 13 over 2. Okay, or you could have done it this way. You could have multiplied out the brackets first, add 6 to both sides, oops, and then divide both sides by 2. And we get the same answer. Question 5.
So would you get right if the x equals 6? No. Yeah, 6.5.
Yeah, but why?
I didn't do that.
But why?
Would you get it right?
Yes. I can't believe so many people got this wrong. Right, there's a fraction here. We don't like fractions, so we get rid of it. So we multiply both sides by?
5.
No, x, to get rid of the denominator. So 5 equals 7x. Now divide both sides by 7. X equals 5/7.
Oh, I try to work out what 5 by 7 is. I did 1.66 for currency. Is that right?
Can we not call out because otherwise it disturbs this recording for people. Question 6. 5 over x minus 1 equals 3. So again, we've got a fraction. We want to get rid of the fraction, so I'm going to multiply both sides by x minus 1. So multiply this by x minus 1, I'll get 5. Multiply this by x minus 1, I'll get 3, x minus 1. Not take anything over. No. Right, look what some people are doing here. You're going, add 1 to both sides, and you're going, but that's not adding 1 to both sides. That's adding 1 to the denominator of one side and adding 1 to the other side. It's not adding 1 to the whole of both sides. If you're going to add 1 to both sides, you do this. Right? You can't just add 1 to a little bit of a side. It's got to be to the whole of the side. Right, so then we can divide both sides by 3 and add 1 to both sides. Okay? So now we can convert 1 into thirds. That's 3 thirds plus 5 thirds, which is 8 thirds. Okay? Question 7. Nice and quiet, please, boys. X minus 1 over 2x plus 1 is 4. Again, we've got a fraction. We want to get rid of the fractions by multiplying both sides by the denominator. So multiply both sides by this 2x plus 1. Okay? Now multiply at the brackets. Now get the x's together. So I'm going to subtract x from both sides. And I'm going to subtract 4 from both sides. Okay? Subtract x from both sides. I get 8x, subtract x goes to 7x. X minus x is nothing. And then I'm going to subtract 4 from both sides. Minus 1 minus another 4 is minus 5. And 4 minus 4 is nothing. And then divide both sides by 7. Okay. Question 8. 4x minus 3 is x plus 5. Here I've got x appearing twice, so I need to get them together. Subtract x from both sides. I get 3x here, 5 there. Add 3 to both sides. Divide both sides by 3. It'll be on YouTube. You'll get a link. Hang on. Just wait. At the end. 4x over 3 minus 2x over 5 equals 1. We've got fractions again. How do we get rid of them? We could multiply both sides by 3 and then by 5. Or we can do it in one go by multiplying both sides by 3 times 5, which is 15. Okay, so we're going to multiply both sides by 15. So if we must multiply all of it by 15. This by 15, this by 15, and this by 15. Too many people were forgetting to multiply the whole thing by 15. Okay, well, let's just write it in the same way as I did before. Okay, I've just multiplied both sides by 15. 15 divided by 3 is 5. 15 divided by 5 is 3. All right?
Wait, what? 5 times 4x. Where have you got the 5 times 4x from?
Because 15 divided by 3 is 5. 15 divided by 5 is 3. The whole point of me multiplying through by 15 is it gets rid of the 3 and the 5.
So don't you have to do the brackets on the 2x and the 5 on the second one, then 15 on the outside? No?
No. Guys, why do you complicate everything? Look, okay, I'll do it again. Listen carefully. Let's say we don't multiply both sides by 15, but we do it bit by bit. Multiply both sides by 3, okay? Just by 3. So I'm going to multiply all of this by 3 and all of this by 3, okay? So if we multiply this by 3, what do we get? 4x.
4x.
Now we must multiply this by 3 as well, and that gets 6x over 5.
9. Oh, no,
Yes.
So what's 5?
Look. 2 times x over 5 times 3 is 6 times x over 5.
Yeah, but what about 6x over 15?
No,
Don't times 5.
no,
Why not?
because then you're timesing it by 5 at the top, 5 at the bottom, they cancel out, you're timesing it by 1 and not 5. No, if you multiply... Guys, let's not interrupt too much, but if you've got a fraction, like 3/5, and I'm multiplying it by 5, you don't multiply the numerator by 5 and the denominator by 5, do you? No. You multiply the numerator by 5 only.
I have the denominator by the denominator.
Yes. Okay, which is 1 in that case.
So how come you times the bottom, the denominator on the left side? So 4x.
Because the 3's cancel. If I multiply this by 3, I get 12 over 3, which is 4.
Yeah.
Yes?
Yeah.
Now, on the right-hand side, I must multiply by 3 as well. Okay, now I'm going to multiply by 5 to get rid of this. So 5 4s are 20, x, minus, multiply this by 5 and the 5 goes, multiply this by 5 and I get 15. Now I subtract the 20 and the 6 and I get 14x. Divide both sides by 14.
So.
Hang on, Lewis, enough now, please, okay? You're interrupting too much. Question 10. 2x plus 5 over 5 minus 7x plus 1 over 7 equals 1. Right, a couple of things to note. Number 1, we've got fractions. We don't like them, so we're going to get rid of them. Number 2, this is the subtraction of all of this fraction. All of it. Yes? Not just a little bit of it, but all of it. You might want to put this in brackets to remind yourself that I must subtract all of that. Right, so let's multiply through by what? 35. Yes, the lowest. So I could do it multiply by 5, then 7, but I'll do it in one go. So if we multiply this by 35, that's all I've done. Yeah? Imagine me covering these things up. If I covered those up, it would look exactly the same as the line before. All I've done is multiply everything by 35. Yes, Jack.
Why is on 1 of the, on 35, 7x plus 1 over 7? You put the
Doesn't matter, does it? Doesn't matter. Look, if I say 2/3 times 4, I can either say 2/3 times 4 or 2 times 4 over 3. Can't I? Yeah? So it doesn't matter. All right? So, now we do the cancelling. 35 divided by 5 is? 35 divided by 7 is?
5.
Right, okay, so now we get 7 times 2x plus 5 minus 5 times 7x plus 1 is 35. Notice the fractions have gone. Multiply the brackets now. 14x. Now be careful. Minus times the positive, minus 35x. Now what? Minus 5. Watch this negative here. Equals 35. Classic error. Catches people out all the time, and it shouldn't. Gather the x's together. 14x minus 35x. Minus 11x. 35 minus 5.
No, isn't sir. So no.
Yes.
11 plus 14 is
21, sorry. Minus 21. Beg your pardon. Okay? Right, so now we subtract 30 from both sides and divide both sides by minus 21. Okay? Now, if you put the minus up there, it's fine. But then I can multiply top and bottom by minus 1. So if I multiply the top by minus 1, I get minus 5. And then multiply the bottom by minus 1, I get 21. So it doesn't matter where the minus goes.
So it's down on 5. X equals 5 over minus 2.
Minus 5 over 21. Or 5 over minus 21. Or minus 5 over 21. Doesn't matter.
So it makes the whole thing minus 1.
Yes? So does it if it's minus 5 over 21.
So if it's 1 minus the fraction of a minus fraction.
Right. Question 11. 9x over 5 minus 2 is 3x over 5. Nice and quiet now, Alex, please. Okay, we've got 5s on the bottom. Let's multiply through by 5. Let me tell you what people did. They correctly did that, then they forgot to multiply that by 5 here. Add 20, must multiply all of it by 5. Now subtract 3x from both sides to get the x's together. And add 10 to both sides.
X equals 1.
Divide both sides by 6.
What's number 3x?
That's a 5. These are all 5, sorry. Not very clear, is it? Okay. Question 12. AX plus BX minus C is 0. Shh. Concentrate, please. Find this hard? Concentrate. First thing, I want just the x's on themselves. So I'm going to add C to both sides. Concentrate, please, boys. Thank you. Now here I need to factorize x out. Okay, I want x on its own. These are multiplied together, this x and this bracket, so I'm going to divide both sides by a plus b. It's not an O, it's a 0. You very rarely see equations with O's in them, because they look like zeros. Well, if it was an O, this would be O minus C, this would be O minus C, and this would be O minus C. Okay? I'll give you the marks, but it's a 0. It's a 0. It's a 0. But you wouldn't see an O. Okay? You wouldn't see it. Guys, concentrate now, please. Shh. Number 13. X brackets 4 minus b over a is 7x plus 1. Just, can I come back at the end? Oh yeah, this should be plus, yeah, because obviously with that change, I've messed it up now. 1 second, go back here. This should be a C, okay? Not O plus C, but just C. This should be C, and this should be C. Right, okay. We've got a fraction. We don't like them. So we're going to multiply both sides by A. So if we multiply the left by A, that gets rid of the A. Multiply the right by A. We must multiply all of the right-hand side by A. Now we want to try and get these x's together, because look, there's one over there and there's one over there. All right? Well, there's actually 4 over there and 7a over there. Multiply the brackets. 4x. Oh no, let's not multiply the brackets, sorry. Let's leave these brackets alone. 7ax plus a. Do you agree?
Yeah, but that a just messed everything up.
Right, I want all the terms with x's. Imagine b is representing an unknown number. Henry, you're not listening. B is representing an unknown number. Okay? So if b is a number, 4 minus b is also a number. So this is just a number of x's, isn't it? A bit like 7x is just a number of x's. 4 minus b, lots of x, is just a number of x's, all right, depending on the value of b. So what I'm going to do is I'm going to just subtract 7ax from both sides. And now I've got x in this term and this term, so I'm going to take it out as a common factor here. I'll use square brackets just so that you can see the difference between the brackets. So now we've got 4 minus b minus 7a equals a. Okay, so all I've done is taken out this x as a common factor from these two terms. There.
Yeah, but what do you use to get it over? Divide it.
I subtracted 7ax from both sides. So the 7ax gets removed from here. Now this is just a number. 4 minus b minus 7a is just a number. If a and b are numbers, then 4 minus b minus 7a is just a number. So therefore I can divide through by that number. And the brackets are superfluous on the denominator. I don't need that. Okay? Hang on. Can I finish off because there's not much time left? 14. This question said the square root of x over 2 equals 5, I think it was. Right, now if we did this by the construction method, you would see that we start with our x, we divide it by 2. Oh, my pen's gone funny now. No, it's electric special pen. Anyway, hang on, before you go, I basically need to square both sides to get rid of that. And then multiply both sides by 2.